Hi, I'm Matt, and in this video we're going to talk about how to evaluate a one-sided limit. So, first, what do we mean when we say a one-sided limit, or you'll also hear them called handed limits? So, first off, when we typically say a limit, we're referring to what is a two-sided limit. It's two-sided because we're looking as we approach x equals a from the left and the right. So, two sides, two-sided limit. And when the limit from the left and the limit from the right, where we're approaching, aren't equal, we say that the limit doesn't exist. On the other hand, we have a one-sided limit. A one-sided limit is when we're only approaching that x equals a value from one side. So that gives us two possibilities. We could approach from the left, which is called a left-handed limit, or we could approach from the right, which is called a right-sided limit. And these are the two possible types of one-sided limits we can take. So these two limits are entirely independent of each other when we look at the left hand and the right hand limit. One cannot exist and the other can exist. They can have totally different values, but again, that's okay because it's only the one-sided limit. So we don't care what the other side is doing. So before we go on to how we find them, we also need to talk a bit about the notation. So first, for left-handed limits, what we do to write this in the limit form is we add a minus when we say that x approaches a. The minus in the superscript shows that we're approaching from the left, or we're approaching from values that are lesser than the value we're looking at. And if we're looking at a graph such as this one, and we have point A here, the left-handed limit is, again, when we look from the left, so we would be looking along that arrow. And now for a right-handed limit, or a limit from the right, instead of a minus, we superscript a plus after the value of a we're looking at to insinuate we're coming from an x value with a larger value than a. And if we look at the graph, as you'd expect, we're now looking down that arrow. So now, how do we find a one-sided limit? So if we start with a graph, we're just going to look at the graph and figure out what value is being approached from the left and what value is being approached from the right, whichever we're actually asked for in the problem. If we're given a function, the first thing we're going to do is we're going to try to evaluate a two-sided limit. Because if the two-sided limit exists and gives us a value of L, then both the left-hand limit and the right-hand limit will also have to equal L. So again, if the two-sided limit exists and is equal to L, the left and the right-handed limit are both equal to L. And then we'd be done. We would have found both both of our one-sided limits. If when we evaluate our function we get an indeterminate, we get something that's undefined, then we can't just take the value of the limit and apply it to our left and right-handed limit. If we get this where we don't get something that we could work with, we're going to need to sketch the graph in the region of interest, or sketch the graph around x equals a, and actually look at the behavior as we approach from the left and look from the right. And again, depending which we'll do will depend on what the question is asking us. And just another note I wanted to make, so just as earlier we said if the two-sided limit is L, the left and the right-handed limit also have to be L. Similarly, if the left-handed limit equals the right-handed limit and they equal L, then we know the two-sided limit will have to be L as well. So now let's try our first example. Here we're asked to find the left-handed limit, the right-handed limit, and the two-sided limit as x approaches 3 of x squared. So the first thing we're going to want to do is we're going to want to try to find the two-sided limit. So we'll take the limit as x approaches 3 of x squared. And now to evaluate this, if you've seen my previous videos, what we're going to do, we're first going to write the function, and then we're going to evaluate it at x equals 3. Plugging in that gives 3 squared equals 9. So we see that our two-sided limit does exist, and it gives us 9. So, since our two-sided limit exists, as previously stated, we know that our left-handed limit and our right-handed limit have to have the same value as the two-sided limit. So here we get that the left-handed limit of x squared is equal to the right-handed limit of x squared, and we find that those are both equal to 9. So that's it for this example. For our next example, we're going to evaluate the limit as x approaches 0 from the left, right, and then the two-sided limit of absolute value of x over x. So just as in the last example, we're going to start by plugging in our value. So we're going to start off, once we write our question, by writing our function, in this case absolute value of x over x, and then evaluating it at x equals 0. Doing so gives us 0 over 0. This is an indeterminate, so we can't use the trick from the previous question that the two-sided limit is also our left and our right-sided limit. So instead, we're going to want to graph the function. So for this one, what I'd suggest doing is plugging in values close to x equals 0. So let's try plugging in x equals 0.5. The absolute value of 0.5 is just 0.5, and when we divide it by 0.5, we get 1. Similarly, if we plug in x equals 1, we just get 1 over 1, and we get that f of x is 1 again. We'll notice that this trend will continue for all of our positive numbers, and the right side of our graph looks like this. Similarly, if we plug in a negative number, we get something very similar. Instead, though, if we plug in -1, for example, we get a positive in the numerator and a negative in the denominator. And when we divide them, we're going to get -1. So this is what our graph is going to look like. For a little bit of a better picture of this, I've plotted this graph in Mathematica and shown it here. So now that we have our graph, to find the left-handed limit and the right-handed limit, we just need to look along the lines on our graph. So as we approach 0 from the left, we're going to look this way. And what we're going to find is that that limit is equal to -1. So the limit as x approaches 0 from the left, I'm just going to write f of x for simplicity here, is equal to -1. Now we're going to want to find the right-sided limit. So we're going to look along the values that are greater than 0. And we're going to look along this arrow here. And we see that in this case, we're approaching +1. So the limit as x approaches 0 from the right of f of x is equal to +1. So since the limit from the left is -1 and the limit from the right is +1, we find that they are not equal. Therefore, the limit as x approaches 0 of f of x does not exist. I'm going to write DNA. And that is how we would do a problem when we're not given the graph, but we end up needing the graph. Okay, for our final example, we're going to look at the graph given here, and we want to find the left-handed limit, the right-handed limit, and the two-sided limit of f of x as x approaches 2. We're going to start with the left-handed limit. So from the left, we're going to look at values that are slightly less than 2. We're going to want to look along this line here. And we see that here the function is continually decreasing. When a function is continually decreasing, we're going to say it goes to -infinity. So in this case, the limit as x approaches 2 from the left of f of x, again, we're going to say is -infinity because it's continually decreasing. Now we're going to look at the right-handed limit. So we're going to want to look at values that are slightly greater than 2. So we're going to look along this line here. And we see that the opposite is occurring. Here we're continually increasing. So when we continually increase, we're going to say that the limit approaches infinity. So in this case, the limit as x approaches 2 from the right of f of x is equal to +infinity because it's continually increasing. I'm not going to put the plus here because it's implied. So now the last thing we want to do is find the two-sided limit as x approaches 2 of f of x. So we know that our left-handed limit is -infinity and our right-handed limit is +infinity. Since these two limits are not equal, we know that our two-sided limit can't exist. So the limit as x approaches 2 of f of x does not exist. And these three are our final answers to this problem. So now I've provided a few extra practice questions for you to try on your own. The first question gives you the function ln of e to the x and asks you to find the left-handed limit, the right-handed limit, and the two-sided limit as x approaches 2. For problem 2, it's the same question, except we're looking at as x approaches 4 and the function is 1 over x plus 4. And for the last problem, I've provided you another graph to practice when you're asked to find the limits based on the graph. The solutions to these problems will appear in 5 seconds. Okay, so for the first question, you should have found that the two-sided limit was 2, and once you found that the two-sided limit was 2, you could just put that in for the left and the right-handed limit. So all three answers should have been 2. For solution 2, or for the answer to problem 2, I should say, you should have found that the limit from the left gave you negative infinity, the limit from the right gave you positive infinity, and since those weren't equal, you find that the two-sided limit does not exist. And then for the last problem, you should have found that the limit from the left was -3, the limit from the right was 0, and then again, since our left and our right-handed limits aren't equal, we should have gotten that the two-sided limit doesn't exist. I hope you got these. If not, feel free to leave any questions you have about this video or limits in general in the comments below, and thank you so much for watching. Have a great day.